right. Good evening, good evening, good evening. My name is Pancho Kastelski, and I'm honored to welcome you to the second edition of Bytes Code, organized here by Lab Digital. It was 13th of June that we had the first edition of this event. We really liked it. We got a lot of positive feedback from people that were there. We enjoyed it and decided, okay, let's do a second one. So welcome, and I'm glad to see you being part of it. We believe in this, so we already booked a third one. It's going to be 16th of January for now. And we're going to announce more information about the theme then and topics that will be there. I'm glad to see familiar faces, friends, colleagues, former colleagues, and partners in the audience. For today, we have chosen an interesting topic, at least that is interesting for us, which is strategic observability and decision making. We have two interesting talks, two interesting speakers. First, Bram, our colleague, is going to talk about OpenTelemetry and how we use that in our applications and how we measure things that matter. And after that, my dear friend Enrique from Molly is going to talk about how do they make decisions, part with information they gather, but also how do you make decisions when you don't have enough information. I hope you had enough time to socialize, get some drinks, get some snacks. And without further ado, I would like to give the stage to Bram. Take it away.
Hello. Yes. All right. So I will be doing some live coding. So if you're all the way in the back and you're not able to read the screen, feel free to walk to the front and sit down up there so you can actually see what's happening. All right. Let's get it started, shall we? So my name is Bram. I work here at Lab Digital as a lead developer. Been here for almost 5 years now. That's not great. Oops. Okay. Yes. There we go. So this presentation was made for our talk at Frontmania last week. Frontmania, local conference here in Utrecht for mainly front-end focused. So hence the 8-bit styling, which was the theme of the conference. So today I'll be talking about OpenTelemetry and the future of application monitoring. The keyword here is monitoring. Don't worry about the rest, we'll get into that. So, as you might have already seen, we have a problem, right? What is the problem? Modern applications are complex. There's a lot of things happening. It's hard to know what's going on. When errors happen, we're not sure why things occurred or why things broke that we fixed before. Of course, we all want to be known as good developers, right? And as we all know, good developers are able to know what's happening, know what's going wrong, and be able to fix the issues fast. But honestly, you can't, right? Just by knowing your code base, it's impossible to know everything that might go wrong. It's impossible to predict every issue. So we need some help. Another important thing to know is none of us here want to get the call right from the customer saying, hey guys, the site's down. Or I cannot add products to my wish list or whatever. We want to know before somebody has to call us from the client's customer support saying the site's been down for 5 hours. It's not a great look. You can't just do this. You need tools. You need tools to know what's happening. Because we're developers, we like having tools. Luckily, they do exist. Taking a step back, what you can see here is 3 different groups of professionals, all at the top of their game. You can see all surgeons from Formula 1 team with their car and their pit lane, and SpaceX sending a rocket into space. So one thing that's the same for all these groups, like they're professionals functioning at the top of their field, and they have a ton of data available at the tips of their fingers, right? They all have their systems, they get information about their system, either body, a car, or a rocket, to know exactly what's going on and to be able to make changes when they need to. Who of you has been this person, right? At night, laying awake after a release? I definitely have been this person. Pushed some code to production, went home, got in bed, like, wait a minute. I'm not quite sure if I didn't just break this piece of functionality. It's not great to be that person. I don't like it. So, our answer, in this case, is OpenTelemetry. What is OpenTelemetry? OpenTelemetry is a suite of tools and standards and SDKs that enables developers to monitor their projects. What OpenTelemetry does is it tracks a series of events and produces details about each of these events. So, for example, to give you like an actual example, I'm thirsty right now. I would like to do something about that. What I'm going to do is I'm going to walk over here. I'm going to grab my bottle. It be tasty. I'm going to walk back. While I walk back, I'm going to take a drink. So this event of me doing something about my thirst is something we can represent in something called a trace. So here at the top, we can see the top bit for resolve thirst, and including in that resolving thirst, first we had walking, then I grabbed the bottle, I walked back, and while I was walking back, I had a quick sip. And each bar in this trace is called a span. So I don't like talking too much about code, so let's actually dive right into some code, and I hope you guys can see it in the back. A blurb about the product and the ability to add the product to your cart or wish list. I think it's a pretty standard e-commerce site in that regard. So me, as a front-ender on this application, I got a message from Oscar, our salesperson. He said, "Hey Bram, I'm having a problem. I'm about to lose my bonus because sales are down this week. Please take a look into that. I really need the money for my second job." So what I could do, right, is I could just go and click through the site, see if I can find an issue. I've done this, you've all probably done this, but it's not the most efficient way to get through to what's actually going wrong. Because at the first site I do this going wrong. Of course that brings us back to adding the tooling. So let's go ahead and do that, shall we? What we can do in this case is go to our code, if I can manage. We open up our frontend folder. In this case, the frontend is a Next.js app, which makes it very easy to add tooling. We need to add a file called instream. Typing is hard when everybody's watching. instrumentation.ts, there we go. This file is automatically picked up by Next.js just to run some middleware. In this file, we can add a register function, which again is automatically run by Next.js. So we do export asynchronous function register. And in this function, we don't need to do a lot, luckily. Register hotel, imported of course, and all we need to pass here is the service name. Let's in this case call it next server. This is therefore the next server site. I will quickly restart my front-end application, or else probably it won't pick it up. Alright, so what I already have running in the background here is an application called Jaeger. Jaeger is a tool that you can run on your local host to collect traces and represent them in a user interface. So as you might have noticed before, this server was empty, and now that I refreshed it, it suddenly has some things there. One of which is next server, which you might recognize as a name that I just added for the traces. So what I can do is scroll down, get a few more traces because 20 isn't enough, click find traces. And what we'll see here is, well, a bunch of traces. Each of these dots in this graph up top here represents a trace. We can see that they are just represented from the time we started testing them, which was a couple of minutes ago until now, and you can see the duration of the traces on the y-axis. So durations are somewhere between 0 milliseconds and about 1 second. Let's get a couple more up-to-date traces. There we go, that's much nicer. So we can see actually quite a few slow traces, right? Nobody wants to wait for 1 second to have a side load. That's bad user experience. So let's have a look into what's going on. So what we can do in Jaeger is we can just click one of these traces to take a look. So again, what we see here is different spans within our trace, and then durations that are happening. So for example, the first span that we see here is just us getting the page on our next server, and then the little black bar represents time spent in that span, right? Because spans can fall into each other. Each time the black bar moves down, that's where the time is actually spent. So we spend a little bit of time getting the page to Next.js, then we spend a little bit of time rendering the page, and then we spend a lot of time doing a fetch to our API. So probably there's an issue there somewhere. So now, me as a front-ender, I can do what I like doing best, and that is of course blaming the backend. So what I'll do is I'll call the backend and tell him he has an issue and then he needs to fix it, right? So, yeah, hello, come. Yeah, there's an issue on the backend. I'm seeing issues with slow traces to get the PDP. Can you look into that, please? Unfortunately, me being a full stacker, it's my turn to fix it as well. Put on my backend had to take care of this. Of course, traces, being an open standard, isn't just locked to front end. We can use it all across the stack. So we can add it to our backend as well. So what we'll do is we'll go into this file, which is just the first file that our server, our API runs from. It's always best to add hotel as close to the top as possible, so that you have the fullest view. So I need to do a bit more typing here, but luckily not too much. So what I was doing before, right, is I implemented the Vercel library for hotel. You can use the Vercel library when you use Next. There's libraries available for Vue, for Nuxt, for normal React, for anything you like. I just used this one because it was very easy for me to get started with. underwater, what they all do is they implement some basic hotel SDKs. In the backend here, I'll be directly using these SDKs just to show you that you can use like nice pre-configured packages, but just doing it yourself isn't that much harder. So what I need to do is just import the SDK, set up the basic instrumentations. So what these instrumentations do is they give me some standard traces, right? So I didn't actually add any traces to the next server, but we can still see a bunch for the page fetch, for the render, for API fetches. I get those out of the box from the Vercel instrumentation. Now that I'm adding node instrumentation, I'll also get some standard traces for Express. So I import get the node out of instrumentations to just get some default traces going. And of course I need to set the service name. Quickly going to restart the server. And let's take a look in Jaeger, shall we? If we can see anything popping up. Find me some traces. And click a nice go. So we do see it popping up here, right? Our new service, Express API. Ah, there we go, much better. So just as before, we can look at the black bar in the trace to see where our time is being spent. Just before it was in here, right? In the next server doing the call to our API. But because we're adding our API, it automatically gets added to the same trace, which is really nice. You get that free and out of the box, front end through back end tracing, and then back again to the front end. We can see the time actually being spent inside of our API. So yes, that does confirm that the issue is in the API, not in the front end, but it doesn't tell us very much yet, right? It's like, yes, somewhere in the API something is slow. So one of the core features of Hotel is being able to add traces wherever you need them. So I have a sneaking suspicion that my oops. I have a sneaking suspicion that my slowness is somewhere in my database call. Maybe I'm doing too many joins or any other crazy SQL stuff. Typically where the issues are, right? As you can see, this API endpoint doesn't do much other than calling the database. So it kind of has to be there, but let's confirm just to be sure. So what we're going to do is we're going to add a span. Typically, we would put this in a nice utility function, right? Because I'm going to do a fair bit of typing now. You typically put this in a utility function, but I'm just going to type it out now just to show that it's not a lot of work. So I need to import trace. On trace, get the tracer. And start an active span. This span needs to have a name. And a function. Before we close it off, we need to end the span. Let me check if this is correct. I do think it is. So now what we now did is we wrapped our database call in a span. The service is still running, so let's take a look. If we can see this database trace now. isn't look pretty one. I don't like this one. Let's look for a nice one. There we go. And once again, you can see the black bar drop down one more level, right? First, we had it in our API call. Now we get it from our API endpoint being called, all the way down to actual database call. So we have confirmed that the issue is yes, indeed, in our database call. Let's all take a look, see if you can find the issue. Database, fruit. Do you guys see the issue? I do. Let's take out this lovely sleep and see if it has improved things for us. So what we currently see is calls taking up to 1 second. I've removed the random sleep. Let's see if we can find some traces. And yes, our calls are all now nice and fast. We can tell our sales guy Marco, and he'll be happy because he'll be able to buy his new yacht. If we put it back in, we should see this balance going back up again. Yep, back up. So far, what I have been doing is using Jaeger, right? This tool. Jaeger is quite nice just to do some initial investigation on your local machine. But of course, our applications don't run on our local machine, they run in the cloud somewhere typically, as well as this interface is a bit limited. We don't have too many things to go through here. So typically you would use a different service. That can either be a SaaS service or a self-hosted open source service. There are lots of options up there. I won't go into many of them, but you should definitely have a look through them yourself, see what you like, see what fits your budget, and make a choice. What I like using is Honeycomb. It is a SaaS service. I'm currently just using the free trial, which supports for up to 20 million traces a month. So let's quickly see if we can do the thing we did before, right? In Jaeger, but just now in Honeycomb. So I'm going to look for the average duration. Of course, I'm forgetting an important thing. I need to send my traces to Honeycomb. I won't type that all out, it's a bit more. I'll just be copying it over. But so really all that I'm doing is I'm adding a trace exporter here to my backend. And that trace exporter just takes two export options, which is a URL and an API key. Nothing crazy. And then for the front end, I need to do something similar. This is the way it was before, right? I'll just copy this over, where I set two environment variables with, again, just an endpoint and an API key. Let me quickly restart my services. And we can take a look at Honeycomb. There we go. I just did a simple count where we can see just the amount of traces coming in. So Honeycomb allows us to visualize in a lot of convenient ways. For example, I can look for my average duration, where ever a page has an HTTP URL, and I would like to split them by that HTTP.URL. So what we can see now is a nice graph with a nice color per HTTP URL, which was our group by. And at the bottom a table showing our group by with their average durations. So probably you cannot see this in the back. Probably still cannot see this in the back. But what you can see here is that our fruit endpoint is actually really slow. Our cherry endpoint is really slow compared to the other fruits, which matches what we saw before. We can also query by name. So we see our spawns here. These are our names, right? The get endpoint for fruit. And then our database call that we just added. So a nice functionality of OTel is that you can add specific attributes to spawns. Which I'm completely drawing a blank on how to do. But that's okay. Who's your friend, right? Oh, never mind. That's going to take too long. There it is. I was just confused because it didn't show before. So I'm now setting the attribute with the name of fruit, and then the value is the value of the actual fruit. Which allows us to now do a group by on that attribute, fruit. There we go. So, what I was trying to show, we can now add attributes to help us more easily find the correct data by allowing us to query for it directly. So, if we hadn't known what the issue was in our database, we could have added an attribute and used that to quickly get to the source for issue, which would have shown us that, again, our fruit cherry is the issue in our database call. Alright, let's move on to a different issue, right? So I'm getting a new message from everyone's favorite sales guy. There's an issue actually with our lemons. He's telling me, well, we have an issue with our lemons, they're not selling well, please take a look into that. And we are losing our Google page ranking for our lemons. So Google page ranking, of course, is based on a lot of different things, one of which is our core web vitals. For those of you not familiar with core web vitals, it doesn't matter entirely too much. Just know that if you do a front end, core web vitals are important. There's 6 different metrics, and the total score of these represents your vital health. And having good health is important to have a good page ranking. If one of these metrics drops, that reflects in a bad user experience, and your Google page ranking will drop. Luckily, we can track our core web vitals using hotel as well. So let's quickly set that up. What we need to do is we need to go into our layout components for our front end. And have our client-side instrumentation set up here. And this component is the component which imports another SDK. It does a lot of things right, but the important thing here is that it's tracking these 4 web vitals. And we can have them represented in Honeycomb as well. So let's take a look. Here's the old queries. And let's see if we can find some issues. So let's see if we can find some CLS issues. So we're just going to look for spawns where we do have a CLS rating, and let's group by that CLS rating. What we can see is we have quite a few good CLS ratings, but we also have quite a few poor CLS ratings. So let's maybe see if we can find where we have those poor CLS ratings by using the group by function some more. Let's group by path as well. And what we can see is most of our pages have a good CLS rating, but our lemons aren't doing as well. Let's go visit our lemons and see if we can maybe also see the issue just as users. Ah yeah, that's pretty clear, right? Well, I don't think this is very clear, it's coming back. But someone added a bunch of banners at the top of the page which really move all of the content on the page down. So CLS stands for content layout shift, and it's annoying, right? Whenever you go to a page, you try to click a button, and then the button just moves all the way down. It's very annoying, and that's why having a bad rating is bad for page rankings. So let's see if we can fix this real quick. Let's go to our notification component and fix the styling. So that instead of a relative component, it's a fixed place. And what we see now, it just overlays the rest of the page, and it overlays each other, allowing us to no longer shift the whole page when we load it. Hopefully this fix will be represented in our honeycomb. We have a filter specifically on our lemons, because we're not interested in the rest anymore. And what we can see now, just here at the very end, probably can't see it from the back. If I wait a couple more seconds, you'll see it more clearly. Is we now only see the green line, which represents a good CLS rating, and we no longer see all of the poor blue lines popping up. So we have indeed fixed the issue, and Marco will be happy. Of course, there's a bunch more things that you can do. I won't be going through all of them now, but I quickly wanted to give some examples. The first one is dashboards, right? You can do all these queries, but it's not very nice to have to always keep doing them one by one. So what you can do is you can set up a big dashboard to show you many different queries that you like using all at the same time. Once we started using this dashboard in an actual project, it helped us find some real issues real quickly and resolve them. Another nice feature is something called deploy markers. So you see the graph of the dashboard before, and this black bar down the middle here is the deploy marker, which shows us, hey, at this point you deploy this new version of the application. In this case, what you can hopefully see is that you have a score of about 85 before deploy, and after deploy we drop down to about 80. So that really flummoxed us for a while, like why are deploys affecting our core web vitals so bad? Turns out, every deploy, we delete our cache. So we just completely lose all of our cache pages. We have to build that up, so it will improve over time. But just after deploying, we do lose some performance. Of course, the solution is keep your cache. And another key feature for me, what I mentioned before, right? You want to know if something goes wrong with your site before anybody else does. You don't want to get the call from the customer support saying, hey guys, the site's down. What I really like is having triggers. You can set up triggers for specific queries. For example, hey, if my average page duration is more than 1,000 milliseconds, please send me an alert. And the alert can be anything, an email, an SMS, a PagerDuty call, a Teams integration, whatever you like. Just to let you know something is wrong with your site, you should look into that. So we have tens of these alerts set up. And actually, just, when was it launched? I think Tuesday? Yeah, just Tuesday. It just kind of saved us because we started dropping a lot of our product detail pages. We lost, I think, well over 50% of our product detail pages. Luckily, nobody had to call us, but thanks to our alerts, we knew within 10 minutes that something was going wrong, and we could resolve it within a couple minutes more. So that does show the value of having good alerts set up. To summarize what I've been talking about, software is hard, right? Many things can go wrong. Sometimes there are things within your sphere of influence, and sometimes they aren't. What's important though is to know what's happening, and you shouldn't just base your knowledge of what's happening based on your instincts or your best guesses. You should use tools and metrics to know what's happening. You should always get the metrics before you make a change and compare them after when you make a change to know how your change has affected your system. OpenTelemetry is a great tool to get these metrics. It's a very nice open standard. What I've been showing you, of course, is just JavaScript, but it exists for Python, Java, Go, anything you like. And there are many tools around it, such as Honeycomb, but also free and open source implementations that you can use. And it's key in resolving these issues. And finally, what I want to leave you with is it's actually pretty easy to get it going. I showed you, it just takes a couple of lines of code, not much more. If you don't have it yet, you should probably go home and implement this tomorrow. Thank you all. Any questions? Come right ahead.
Okay, so hi, thanks. Great talk. In the case of client-side instrumentation, does the browser actually emit the traces, or does it send it back to the backend, which will then send it? Because if the browser does it, it means you have to embed the API key into the browser, which means it's accessible for anyone visiting the page.
Yes. So, I've had three kinds of tracing actually: the API, next back, next server, and next client. And yes, the next client token does get set out from the browser, and it does include the API key in the header. It's just the way it is. Honestly, we haven't seen it be an issue. I mean, sending traces to your application isn't that interesting to mess with, I think.
Yeah, I think Sentry actually explicitly declares in their documentation that these keys are just public information.
Yeah.
If you send too much, you'll get rate limited in that sense. I guess it's fine.
Yeah, they're not.
Thank you.
In regards to the implicit instrumentation things, do they change the code that then gets compiled, or is this some sort of hook that it's at the runtime level? Rather, for the implicit spans, the first step that you showed.
Yes. So the implicit spans, these are just instrumentations, they're just added to your bundle. So you install the SDK, it adds it to the bundle as some middleware. Does it answer your question?
So it doesn't change the source for those ones. It doesn't actually there isn't like a pre-processing step where it injects explicit spans in an intermediate compilation step that you never see in the editor.
You will not see them. No, they are magic in that sense. So it does not change your code. It just uses, in this case, the Vercel package that I used, just uses some hooks available by Vercel to set them up. But no, you will not see them in the editor. And yes, in that sense, they are magic. So personally, what I like doing, or what I prefer to do, is just to use it to get started, to get some information, and then replace them by your own smaller set of spans. Because they can be a bit noisy. When you go to Honeycomb, you see like a huge list of spans. I don't like it that much. I like having a bit more control. So I prefer setting up my own spans in my own hooks that you can indeed see in your editor and have full control over.
And as a segue, the explicit spans, do you ever find that you want to remove them afterwards, or for by and large they are meant to stay forever in runtime?
Sometimes, when I'm debugging a performance issue, I add too many spans and I do end up removing them. Because I'm just like maybe here, maybe there, maybe there, maybe there, and then it's too much. And then typically you can end up keeping one or two that are like at most risk of causing issue, and you remove the rest that are just like computational milliseconds.
Thank you.
Are there any other questions?
Thank you, it was interesting topic actually. I just wanted to ask, have you tried another tools, or why you choose this one?
You mean Honeycomb in this case? Or OpenTelemetry?
OpenTelemetry.
I mean, in essence, OpenTelemetry is not much more than console logs with performance notations. So I suppose you could say, I have done that. That's not great, right? And you can go and collect that from your logs, but having the standard, which is built specifically to do this, is much nicer. So yeah, yes and no, I guess.
So how does OpenTelemetry then stack up to things like Dynatrace or Datadog?
It doesn't stack up to, it's the implementation used by. So you can send your OpenTelemetry spans to Datadog and Dynatrace. They're just alternatives to Honeycomb. And that's just a matter of, well, both price and feature set, right? Thank you, everyone.
All right, we're going to take about a 10-minute break. Toilet break, drink, snacks, and then we'll continue with the second talk. Thank you.
Thank you.